Okay, so let's pick up for where we left off last time. We were writing a remember statement. Let me open up the slides too. We were adding a resolve statement rather to our language and upgrade the parser so we can parse a statement of this type and add them to our list of statements. Okay, so, and I know this was asked on Slack. So if we were thinking about the Java version of a remember statement, we would say something like int a equals 5. And if we were saying the Java version of a resolve statement, we would just say a. And this would resolve to a 5 is how it would ultimately work. Okay, so that's what we're writing here. So we're kind of drilling the two sides of our variable environment we already created. So one thing is we want to be able to add things to our variable environment. The other side is we want to be able to look up things in our variable environment. So here in our parser, so just kind of reviewing what our parser currently does, we create a list of statements, which is going to be a statement. And let's go look at statements. So a statement is going to have a type, and then it's going to have the ability to show itself. Now we created two different kinds of statements. Well, right now we have one kind of statement. So we have the idea of a remember statement. So a remember statement is a normal statement, and it's going to keep track of a name, a type, and a value. And when we create this remember statement, we'll go ahead and create our parent, which is just statement, which is going to keep track of a type, statement type. So we'll go ahead and create our instance of our parent right here, and then differentiate ourselves by setting up our name, type, and value. Actually, let me look at this real quick. Oh, that's statement type. Okay, yeah. So the type for this is going to be like the like int char, that kind of stuff, I think is what we had decided. Let me look at what an input.spider looks like. Yeah, remember int a equals 5. So this would be a remember statement. This is the type, this is the name, this is the value. Okay, and then we're going to have a couple of resolve statements in here that we want to give support for now. All right, so in any case, just continuing to go through here. So this is a constructor for a remember statement. We then have a toString for it, so we can see what a remember statement looks like. I think if we run this right now, it currently has a, hold on a second. That is, I'll run this guy right now. So that's our remember statement and our remember statement. So it's showing the two things there, because right now, even though we're reading in lines for those other ones, our parser doesn't know how to deal with it yet. Okay. So that's what the toString does. And then we just have getters for the pieces of a remember statement. All right. So now we go back to our parser. When we first create a parser, a parser is going to be like a factory. So we don't actually create instances of this guy. Instead, we call parser.parse. And because this is a static method, parser.parse is going to take in a file name that we want to read from. So right now we have this input.spider that we pass it from driver. So there's us calling parser.parse, passing an input.spider. And then after it's finished parsing, we're calling our parser to display itself, which should show the list of statements that we're eventually going to interpret. We're not interpreting them yet. All right. So we read in from the file. We add all those elements to a string. So what this guy right here effectively does, if we wanted to put a little comment here, is it builds a single string that has the contents of the file. So we're reading in the entire file into this single string. All right, and then last time we had printed that out, proving that we had done that. So that's what that line was. All right, so now since we've, in our spider, we have semicolons at the end of all of our statements. We went ahead and we're splitting on a semicolon. So that should give us a string array of program lines that we want to then go through each of those lines. So each of those lines in there is a statement. And what do we do with statements? We parse statements. So let's go look at parse statement. So parse statement will take in a single string, and this string is representative of a single statement from our file. And then we will split that guy on white space, if you remember what we did last time. So this is split the string on white space. So that is one or more spaces in this case. So that'll give us a string array of parts where, for example, if this was the string that came in, bucket 0 would be remember, bucket 1 would be int, bucket 2 would be a, bucket 3 would be equals, bucket 4 would be 5. If this were the example that came in as s. All right. So then we're going to ask, what does the first element look like? Because remember, we're kind of, if we look at our input.spider, we're looking at the very first thing in here, and that tells us what kind of statement we're dealing with. So if it's a remember statement, that means it's one of these guys, and we should have 5 parts. Then what do? I'm going to add a parse remember, passing it the type, the name, and the value. Those are the pieces from that guy. Okay, so this is build, well, let's call it parse a remember statement with type, name, and value. And we are ultimately adding that to our list of statements. All right, so that's for parse remember. If we're looking at a parse resolve, which is the thing we were doing for our homework, else if we're looking at a resolve, we're going to call parse where's our parse remember? Here's parse remember. So what we're going to do is we're going to have one called parse resolve. And this guy is going to return a resolve statement, okay, which is going to be very similar to a remember statement, okay, where we read in the pieces of information. So in this case, for a resolve, we only have a single part. We have the word, this is the type, and then we have the one thing that we're resolving. So we're going to go ahead and create our object. So the first thing here is we're going to create an object for our resolve statements. So I'll create a new class. And this is going to be a resolve statement. Like this. And we're going to say that resolve statements extend a normal statement. So then we'll have our public resolve statement for our constructor. And this guy is going to take in just a name. Go ahead and call our parent constructor, letting them know what kind of thing we are. And I just want to follow the model we used here. Okay, we called it a remember statement with a space there. So we'll call this guy a resolve statement with a space. That's just kind of labeling it so we can use that later on. So this is a resolve statement. All right. And then we'll go ahead and we're going to keep track of a private string called name, which will be the variable name that we will want to resolve later on. Okay. So there's the name. And keep in mind, we haven't written the interpreter yet. So we're not resolving these things yet. We have the variable environment to do it, and we're going to start moving towards that today. But right now, all we're doing is writing the parser. Okay, so we're taking our syntax that looks like this and turning it into Java objects that we can then interpret into logic later on. All right. So back in my resolve statement. So this is what my resolve statement will look like for, it's going to have a name, and I'll say this dot name is equal to the name that was passed in. So that's the constructor for that guy. Now I'm going to go ahead and steal my toString from my remember statement, just so I can take advantage of the format that it already has. So I'll go ahead and call my parents thing here, but then all I'm going to put out here is the name. So this guy is going to print out the type of statement. That's what the parent does. If you remember in statement, it prints out, this is a statement of type. In this case, it would be resolve statement. Followed by a carriage return and a tab that'll indent it underneath it just to make it look pretty or something. And then we'll just say this is the variable name that we're resolving, just to give us a feel for what this thing will look like. Okay. Again, that is so we get something that looks like this for our resolve statements. Right now, we're parsing 2 remember statements, and we do have 2 resolve statements inside of our code, but we don't know how to parse it yet. That's what we're adding. All right, so this is going to be our object for doing that. I'll go ahead and give myself a getter for name here. So I'll go in here and do source, generate getters and setters. And I'll just give myself a getter for my name. And all that did is that just generated this little chunk of code. You could have easily just written it by hand. So that's just a shortcut in Eclipse for generating getters and setters. In this case, it probably would have been just as fast just to write it. Where it really comes in handy is when you have a whole bunch of fields up here, 5, 10, 15 fields. You can just do what I just did and generate getters or something for all 15 fields pretty quickly. So it's a convenience thing. All right, so there's our resolve statement for right now. And then we're going to go ahead and go back into our parser and go down to parse statement. And here it is. If we're looking at a resolve, we want to do something pretty similar to what we did up here, but we want to have a parse resolve function.
Yeah. Instead of remember resolve.
That's right. Yeah. So we'll go ahead and write a, back here, I'll steal this just as a baseline for time. Oh, and do remind me, I need to end class around 11:30 or so today. So if I start getting close to that and I'm not shutting up, somebody tell me to shut up. I'll show you here the toString method. When I call display, somebody asked in chat, what does this toString method do? So here in display, I have a collection of statements inside of my list of statements. When I say system.out.println and I pass it a statement, this is an object. What the println method does is it automatically calls that object's toString method. And the reason it can do that is because all objects have a toString method by default. It's part of the object class. I'll show that to you. So if I say Java object class, this is the thing that all objects come from in Java. They all extend object. And you'll see down here that generic objects have a toString method that returns a string representation of the object. And the default string representation of the object is like a memory address looking thingy. Okay. So by me giving my all my statements a toString, I'm saying instead of showing the memory address thingy, show something else. So if I'm printing out just the statement, it'll say statement, blah, blah. But if I'm doing one of my specialty kind of statements, like a resolve statement, toString goes ahead and prints out, uses the parent's version of this, but then adds to it the additional things that make it look like a resolve statement. So the only reason we've named it toString is we want to specifically override the default version of this that we get from our parent. And we're guaranteed to get one of these from our parent because at the very top of the line here in statements extends object. This is something that's kind of invisible there. So a statement is a generic object, which does have a toString. All right, so back here in Parser, we're going to write parse.
I have a question.
Sure.
I do remember in C# we need override on the toString. Does it mean Java doesn't need override keyword, or it doesn't have it?
It doesn't need it. There is these special formats for in Java that helps the compiler operate a little bit more efficiently. It's like I think it might be like a capital, something like that. There's like a symbol you put before it that helps the compiler operate a little bit more efficiently, but it's not necessary because when a method is resolved, it resolves to its most local definition. So when I'm inside of parser's display and I'm trying to println S, where we know S is either an instance of remember statement or an instance of resolve statement, the most local definition of toString, which is what println tries to call automatically, would be this guy. If I didn't have this guy written, if I just call it toStrings or something, rename it. If I didn't have that guy written, see how I get my statement that looks like this now, because it no longer calls this guy. It now just calls the parent's version of that, which is this guy. And if I rename that one so it purposely has a different name, now I'll get a memory address thingy. Because this is the default toString method. So methods resolve to their most local definition. And if I'm calling display on a resolve statement, or a remember statement again, if I'm doing this, and I rename this to toString, like that, but let's say I leave his parent, which is statements toString alone. What this is going to do is this is going to give me memory addressy thingy followed by the special stuff for remember statements. So there's my memory address thingy and then int a equals 5. So I am guaranteed by the way Java is created that all objects have a toString method. So I'm guaranteed that this line will work. Even if I have not written anything special inside of this object, it will by default get the baseline toString method from object. So I can go back into statement now and change this back to toString, which now, to your point, will override the version it gets from its parent. Language theory term for that is it's said to shadow the method that it would have inherited. Because statement, since it extends object, automatically inherited his own version of toString. That was the default one. When I wrote my own, I shadowed the one that was already there, and it will resolve first. But like we saw here in our remember statement, I can choose to include my parents here. Similarly, if I go into statement, I can, return super.toString concatenated with statement. Let's just do that. And now I have all three of them. So now we're asking objects toString to play a part, statements toString to play a part, and remember statement to play a part. So there's our memory address thingy. So that's our objects toString. This is our statements toString. And then this is our remember statements toString. That makes sense?
Yes.
Okay, so let's see, where were we? Back here in parse, we're writing our parse resolve, and this guy is going to return a resolve statement instead of a remember statement, and he's going to take in just the name because that's the only piece that resolve statements have is a name. And I'll just change my little comment there to this guy returns a resolve statement. And we're going to create a resolve statement. Built with just the name. And then we'll return it. So this is what parse resolve statement will do. So that means I need to go back into parse and make sure when I call this guy, I pass it just the one piece of information. So that's back down here. In parse statement, if it's a resolve, I'm going to do something that looks a lot like this. But I'm only going to pass it the name. So bucket 0 would be equal to resolve. Bucket 1 would be the name that we're looking at. This guy right here. That's bucket 1. All right, and we're going to be calling parse resolve. All right, so now we taught our parser how to parse resolve statements as well as remember statements. So back out here in driver, what do? I read in input.spider, I parse it, then I display. So I should get all 4 statements now. Notice I have 2 remember statements, and then I have my 2 resolve statements. All right, so that should have been the solution to the homework. Questions about that?
I have a question.
Go ahead.
So in the, can you go back into the parser state, the parser class? And then, yeah, like, so when we add using the object, and then we say parser.parse resolve method, but what is the part? So that parser is the class name, parser
It's right up
dot.
here. We get our parts right here. So for example, if S was equal to this guy, parts would equal, remember, int A equals 5. If S was equal to resolve A, then parts would equal resolve and then A. So this is the line that splits S, whatever S is. So S is right now, S can be one of 2 different formats. It could either look like a remember statement or it can look like a resolve statement. That's what S currently looks like in our program. So if S was a remember statement, when I split it on white space, it's going to give me an array of strings that looks like this in this example. If instead it was a resolve statement, when I split it on white space, it'll give me a string array that looks like that. So notice here when I'm looking at something where the first element is a remember, this is bucket 0 of that array. Bucket 0 of that array. If that guy is that, then I want to parse a remember, passing it bucket 1, bucket 2, and bucket 4. The 3 pieces of information needed for creating a remember object.
Okay.
Similarly, if I'm looking at a resolve, if bucket 0 is equal to a resolve, bucket 0 of this guy, then I want to parse my resolve, passing it the 1 piece of information a resolve statement needs, which is the name at bucket 1.
Got it. But what is the parser dot is in the add function?
Parser dot add. Oh,
In the add,
this
that's
guy?
a class name?
Yeah, it's the name of this class. So parser is the name of the class. I'm calling parse resolve, for example. This guy is a static method. Static methods are owned by the class. So I call them using the name of the class dot the name of the method.
Okay, so it does not need to create the object. Okay,
Correct, because it's static.
okay,
As opposed
Right.
to if we look at resolve statements, for example, none of these are static. Well, here, none of these are static. So that means in order to work with a resolve statement, I need to create an instance of a resolve statement, and then I can work with it.
got it.
Make sense?
Thank you. Yes, thank you.
And that, what I just talked about there should be true for C++, Java, and C#. Basically all of our modern, as well as Objective-C and Swift. So all of our modern C-based object-oriented compiled languages use that static keyword to, actually that's not true. Objective-C uses, instead of static in Objective-C, this is more trivia information. If we were in Objective-C instead of static, it uses a plus sign before it, where an instance method is a minus sign. So if you're ever working with Objective-C, see in Java, if we don't have a if we don't have static in front of it, it's considered to be an instance method. If we do have static in front of it, it's considered to be a class method. So in Objective-C, rather than the absence of static meaning instance, an instance is defined with a dash. A static is defined with a plus. Just trivia information for the future if you ever work with Objective-C, which is the core language for Mac stuff, even though that's largely been now replaced with Swift, which I think is a stupid language. I'm sure as we get farther into our interpreter, you'll hear me complain about languages like Swift as well as Python. Okay, yeah, we just talked about that. So parse remember is this guy. So a parser dot, it's static. So parser dot parse remember calls this guy, and we pass it the 3 pieces of information that we pulled out of our parts, and it just builds a remember statement for us and returns it. And then what do we do with that? We are adding it to our list of statements. So in the end, when a parser displays itself, it's displaying the parsed list of statements that we have in there, where our list of statements right now is filled up with remember statements as well as resolve statements. So this is the result of calling toString on a remember statement. This is the result of calling toString on a remember statement. This is the result of calling toString on a resolve statement. This is the result of calling toString on a resolve statement.
And in the file function, it fetching the data from the input.snider.
Which
Finder?
function?
in the bottom here. Yeah, the file name above. Yeah,
That's this
here
guy.
scanner. Yes.
Yeah.
So we are using the scanner input.
When I call parse, I'm passing it the name of the file that I want to read in, which is my source code file. And I use scanner to read in that file. So scanner allows you to read stuff in from the keyboard or from any stream. So the stream I'm doing is a file stream. So I'm creating a new file out of that file name, but I'm specifically telling it to find out my current directory and then /source, because that's where I stored my file. So this is adapted for Eclipse's file structure, because specifically in Eclipse, we're putting our file inside of our source directory. When code runs, it's running out of the bin directory. So that's why we have to specify this here. So this is just giving it the complete path to where that file lives. That's what that effectively does. It lives in the current directory /source/ whatever the file name was. And I'm going to create an instance of a file from that and then use scanner to read in from that file.
And input.has function, it's adding.
Yeah, I mean, just go and look up scanner. So, I mean, you know, you can find out what all these functions do if you just do Java scanner class. There's all your crap in there, and has next is going to be defined down here, and it's going to tell you that has next returns true if the scanner has another token in its input. So as long as there's another line to read, has next returns true. All right, so you can go and look those things up whenever you want to know what an individual line is doing. It's in the Java documentation.
Okay, thank
you. Okay, so now we are.
I have one question, small question maybe. You was telling this, remember is the 0 element and int is 1 and a is second and equal is 3 and fourth is 5. So equal is not mentioned. 330 is not mentioned. I just skipped that. Yeah,
well,
what mean by?
Because this is like, you know, extra syntax. Equal sign isn't something that we need to store. We just need to know what kind of variable it is, what its name is, and what its value is. So that's what remember statements are taking in: the type, the name, and the value. That's why when we create a remember statement, we're only passing it the type, the name.
Oh, this 3 we have skipped. Yeah.
Right. That's why we're not using the equal sign. It's just humanized only.
Okay.
All right. That makes some sense?
Yeah, thanks. Yeah.
Okay. All right. So are we all pretty good on where things stand right now for the code? So let me do this real quick. I'll go ahead and so what was this? Solution for homework 2. And I'll push that to origin. So now my repository should have the most up-to-date version of the interpreter. So for the next assignment, if your whatever you have is not in great condition, you can always use mine as a starting point. Okay. So given that we've built a variable environment now, and we have the ability to look up variables in our variable environment, right? So we can add a variable to it. We can get the value of a variable. Okay, so we can add a name value pair to this guy. We're currently not using types, but we can. We can, and we'll see where that goes here in a few minutes. And then we can get the value of it. Notice that all get values return an int right now. So even though we are storing the type of value in our language right now, we're only actually supporting the type that is int. All right, so we're foreshadowing a little bit for where we're going with that type for our remember statements. We're storing the type, but we're basically assuming this is always int for right now. Okay, but we kind of know from programming languages we might want to store things that are, you know, more than that, more than just an int. We might want to store strings and chars and floats and stuff like that. Ultimately, even objects. All right. So given, and what I'm going to do, let me do a little organization here. So I want to create a new folder. I think this will, I'm going to call this guy Parser. I'm going to go ahead and drag my parser in there. Let me just make sure that the way it creates folders still works, so it doesn't. I'm going to have to use the package to pull this off. Oh, we actually might still be okay. So now I'm going to pull in my remember statement. I'll pull in my resolve statement. I'll pull in my statement. I'm just trying to make it a little bit more organized if I can pull that off with Eclipse's folder organization. Yeah, it doesn't do what I want it to do. Does it automatically put these guys in a package? Oh, yeah, we are good. So I just need to go into, so this is going to work. I'm just going to try to do some organization stuff here because as you can see, as we keep going, it's going to start getting pretty crazy. So notice here in driver, it says that when I hover over parse, it says it's not visible. It's because I have it at package level, which means inside of parser, when I go to parse, this guy needs to be public static. So he's visible outside of here. So now driver should be able to see that guy. Similarly, display also needs to be public. So I can see it outside of this package is what this would be called in Java. Java's package structure is basically a structure of folders. All right, so now that guy's happy and I can run the program again. And this now allows me to kind of keep all my parser crap inside of this little folder, this package. All right, and notice here inside of driver, it went ahead and it imported parser.parser for me because the first parser is the package called parser. The second parser is the class called parser that's in there. So this is go to this folder, go to this class. Give me access to that, and then I can use it in here. All right, so this is just organizational stuff we just did there. All right, now I'm going to go ahead and create another folder for my interpreter. And notice it can create it as a package, but I'm just going to use folder because I think it will automatically update the stuff for me. So I'm going to call this guy the interpreter. And then I'll go ahead and put my name value pair stuff inside of my interpreter. And we're not using that right now, so we're okay with that. All right, so right now driver just reads in from a file and parses it. So now my parser has my parsed stuff. So what I want to do now is I want to write an interpreter that will interpret those lines. So what's the job of an interpreter? So we go back to our slides here. I probably already have this in here. We talked about the parser. So the parser converts from human syntax into objects that can then be operated on. So then what does an interpreter do? An interpreter uses the results of the parser, i.e. objects built by parsing the human readable syntax. And then it runs those statements and outputs the result. Okay. Now, if we think about this like a normal Java program right now, just go back in here, we only have two different kinds of statements right now. I have int a is equal to 5. And then I have, well, I can't just say a. Here, let me just do, well, let's just start off with this for the example, because resolving statements is used as part of other statements. So if I run just this program right now, I commented out these 2 lines, what would the output of this program be? What will I see on the screen?
Oh, we don't see nothing.
What did you say?
We just see, like the output will be nothing. It just making red.
Yep.
There is
No output. Even though this program is doing something, we can say that our interpreter our parser would convert this into a remember statement. Our interpreter would then take that remember statement, and what do remember statements do? They tell us to add something to our variable environment. So we know that after this line, we now have a variable named a equal to 5 in our variable environment. But we haven't used it, we haven't done anything with it, so we won't actually have any visual version of this. What we'll probably do early on in our interpreter is give some sort of feedback that we did something. So maybe we'd say like remembered a would be the output. You know, that's what we just did, because we don't have more complex statements yet to use remembered values. Okay. So that's kind of where we're going next here, is to be able to start writing an interpreter that can work through a list of statements and do what they say to do. All right, so inside my interpreter, I have my name value pair. So I'm going to go ahead and I'm going to create a new class inside of this. I'm going to call this guy here, we're going to call this guy the spider interpreter. All right, so here's my spider interpreter. And notice here, all these other things I drug in here, notice it added them to the package called interpreter. That's how Java handles its memory. It's a file formats, its folder format is through something called packages. So when I drug name value pair and variable environment into this package called interpreter, it added this thing on top for me. All right, so it makes our code a little bit more organized here for us. And then I just created spider interpreter, and notice this guy's already part of that package. All right, so for our spider interpreter, we're going to have several different pieces of information. Now, we can say that our spider interpreter only exists once. That means we don't actually need to create multiple instances of an interpreter. We could just tell it to interpret a list of statements. That's what we effectively are doing. So most of the stuff we're going to have in here is going to be static methods. So we're going to have a private static void variable environment. I'm sorry, not void, public static variable environment called the env. And this guy will be equal to a new variable environment. If we go and look at variable environment here, you see that creating a variable environment does not require any parameters. So my interpreter is going to have a variable environment available to it. And right now I have an empty variable environment. All right. Now I want to add a public static, and I can just say void for right now. We can decide if we wanted to return something later on. But I can say public static void. We're going to say interpret. And this guy will take in a, did I store it as an array list? I think I did, but let's just confirm. Yep, an array list of statements. So he's going to take in an array list of statements. Called the statements. All right. So when my interpreter is asked to interpret something, what is it interpreting? It's interpreting an array list of statements that is going to be provided to us by the parser. And I can go ahead and connect those dots for you right now. So we have parser.display proved that our parser did what we wanted to do. So I'll just comment that out for now because we might need to use that in the future as we add new things to parse to this. So now we want to call interpreter dot. Actually, I was going to just say spider interpreter, but this is fine. Spider interpreter dot interpret, and I'm going to pass this guy parser dot, and I don't have a ability to get the list of things from my parser. So my parser right now has this static array list. I actually probably should make this a private static array list. And then what I'll go ahead and do is I'll just give myself a public static array list of statements. Get parsed statements. And this guy will just return that private field. All right, so I'll have a public method called get parse statements that will return for me an array list of statements. So now out here in driver, when I call interpret, I'm going to pass it parser dot get parse statements. That's what my interpreter needs. For my spider interpreter to be able to interpret the code, I need a collection of statements. Who has my collection of statements? My parser has a collection of statements after it's parsed my file. That makes sense? So the 1-2 punch, or I guess the 3-step punch, is we write code in here, then we run it through the parser right here. And then the parser gives us a list of statements, which we get right here, and we pass that to the interpreter. All right, that
So I have a question.
Go ahead.
So what is the main difference between the public static and the private static? So because in the docs I
Private
have
static,
that
you can't access it outside of that class.
okay.
So if I'm in parser here, this file or this array, or sorry, this method, because it's public, it can be accessed outside of this class. By making it private, it can only be accessed inside of this class. So I'm basically keeping my parser completely locked down and have all these moving parts inside of it hidden from me, and then only exposing these certain features that I need to use externally. If you want to think about this like your smartphone, you have your phone, there's a whole bunch of details inside of your smartphone that you can't put your fingers on. Those would all be private. But now you do have some things that are public. So I have like this little on-off button over here, and I have some volume buttons, and there's some touchscreen stuff. So there's aspects of the smartphone that are made public to me that I can interact with outside of the internals of this. But all those internal things are hidden from me. I can't conveniently get to them. Does that make sense? That's the purpose of this whole public-private concept. So my general approach is make everything private so that we don't give anybody external access to the wires, and then loosen the reins when you need to. So this guy started off as private, and rather than letting them have direct access to this array list, which would then let them change it, I said, look, if you want the array list, ask me for the array list and I'll give it to you. Now, technically, I think array lists are passed by address. So technically, I think you would be getting the original, and you could still make changes to it. So if you clone it, let's see. I'm not going to end up doing this. I just want to point out the thing. I thought it was clone. Oh, I just need to say that this guy's actually an array list of statements after I clone it. Yeah, that's fine. I know that cloning this object will give me an array list, so I am converting it to an array list. So I'm not going to leave it like this. I just think it makes it unnecessarily complex. But the idea here is that when I return an array list, I'm about 98% certain that array lists being objects are passed by reference, which means that whoever gets that externally, if they make changes to it, those changes would have side effect. We'd see them inside of the parser class. So if I want to be able to give somebody read-only access to my parsed statements, I can go ahead and make a clone of that memory location. So what I'm handing them is a pointer, but a pointer to a copy in memory, so they wouldn't be able to damage the original. But I don't want to take the focus away from what we're actually doing here. So rather than worry about some of those things, since we're the ones controlling the parser and the interpreter, we'll just know that it's not for us to start making changes to whatever was returned by our parser. Those are our parse statements, and we should use them as is and not start removing them or changing them or anything like that. All right, so we'll have get parse statements from this, and it's just going to return our list of statements. So the idea here is we parse this file, which then produces an array list of statements, and then we pass that array list of statements to our interpreter and ask it to interpret it. All right, and that's what we're currently writing. All right, so go back into our interpreter, and we're going to go to our spider interpreter, and we have this interpret function here, and the interpret function is getting a list of statements as a parameter, so an array list of statements. We want to process through this array list of statements, we want to process through this array list of statements and execute each statement. Now I already have my variable environment available to me here, okay? But we're going to keep this fairly segmented, so you'll kind of see what I'm doing here. So we're going to go ahead and we're going to say, let me actually think about this. Yeah, we'll write it this way. It'll be fine. So I'm going to go through each of these statements. So I'm going to say for statement S in the statements, I want to do some stuff. All right. So each time through, S will be equal to the next statement in this list of statements. All right. And I want to ask what kind of statement this is. So because if it's right now I have two different kinds of statements, right? I have remember statements and I have resolve statements. Those are my two options right now. As our language gets more and more complex, we will add additional options to this. But right now we only know two things and they both work off of our variable environment. Okay, so this is like our starting point for our language. So we're just going to have a series of if statements here. So we're going to say if S is an instance of, so this is a Boolean operator built into a lot of object-oriented languages. They have the equivalent of this in most languages. So I'm asking if S is an instance of a remember statement. So it's, and we're going to have to import. I'm just going to import parser.star. So I have everything for my parser because I'm going to need all those things. Okay, so if S is an instance of remember statement, then I want to interpret a remember statement. So I'll go ahead and just like we did before, I'm going to have functions for doing the special kinds of interpreting. So I'm going to make this guy private because we don't need to access this externally. Our external access point is through this interpret function. And then internally interpret can call these other things. So I'll have a private static void interpret remember statement. And this guy will take in a remember statement as a parameter. And his job is to interpret that. So inside here, I'll go ahead and say interpret remember statement. I'll pass it my statement here. And I need to let him know that this is actually a remember statement. Because technically S I've defined as a generic statement, even though if I'm inside this if statement, I know S happens to be a specialized kind of statement. He's an instance of a remember statement. So I'll go ahead and pass him to my interpret remember statement function. And I'm in the process of writing down here that's expecting a remember statement. So I'll go ahead and typecast it to a remember statement. So yes, I know I advertise S as a statement, but it's actually a remember statement. How do I know? I proved it right here. All right, so that's what we'll do. If I'm looking at an instance of remember statement, I'll just ask my interpreter to interpret a remember statement. And what I'm going to do just to keep track of our actions, I'm going to go ahead and I'm going to create a private static array list of, I'll just do strings for right now, called the output is a new array list of strings. And the idea here is that when I interpret a remember statement, because we saw that when I say int a equals 5, the output of that program is nothing. I want to at least put a little string in there saying, hey, I remembered a was equal to 5. I did that for you. Behind the scenes, the variable environment's been updated, but at least it'll give us a little bit of feedback that our interpreter is doing what it's supposed to be doing. And then we can do a dump of our variable environment and prove it. All right. So what do I do if I am interpreting a remember statement? Well, remember statements have a name, a type, and a value. And I can get the name, I can get the type, I can get the value. And remember that our variable environment can add a variable. And right now, when we add a variable, we do not store the type. We just take in the name of it and we take in the value. Okay, so we're going to ignore type for the minute. In fact, let's actually think about that. If we ignore type from the get-go, is it going to be more complex for us to update that later? I think we should leave it alone for right now. Updating it later is not going to be a big deal. Because right now we're going to have plenty of time to do stuff with numbers and things like that. So ints might be good for us for a while. All right, so inside of our interpreter, when we do an interpret remember statement, we want to add something to our variable environment. So we want to say, I like to be explicit when I'm dealing with static things. So I use the name of the class dot the env, and then I'm going to add a variable. What's this variable's name? rs.getName. And what's the variable's value? It is rs.get value. All right, but rs.getValue is giving me a string. Because remember, in our remember statements, we're storing everything as strings. So what I need to do is when I call getValue, I'm going to get this value as a as an integer. So I can do this a couple different ways. I can do it externally, but I'm actually going to do it internally here. So I'm going to say get value here. I'm going to change this to get int value. And actually, hold on, let me do this. I'm going to right click on this. I'm going to refactor it. And I'm going to say rename. If I refactor this, it should change it in all other places in my program where I'm currently using it. So I'll say rename this. I'm going to say get int value. And then what I'm going to return is the integer.parseInt version of value. That should convert that string into an integer. Oh, I still need to refactor here. Actually, I don't, because it's already been changed in places. All right. So I expect now, if refactoring for Eclipse worked the way I thought it should work, when I go into my interpreter here, I should now, nope, it didn't work. So I'll just change it to get int value now. I thought refactoring should have changed that throughout, but it didn't. So it's possible I have maybe it just refactored inside of the class. So if I go back to remember statement, yeah, whatever. All right, so interpret remember statement takes in a remember statement. What do I do for remember statement? I add that variable to my environment. I add its name and its corresponding integer value. Now, so that's already done. I've done that. But now just to sort of mark that this has been done, I'm going to go ahead and add to my output. .output.add. And I'm going to say added. And then we'll say rs.getName. equal to rs.get into value to the variable environment. Something like that. And then maybe what I'll do just for extra good measure is beforehand here, I'll maybe put something that looks like this, hidden, kind of indicating that this isn't output that would be visual. You know, I'm just kind of mentioning that I followed the statement's orders. The statement's orders said add something to the variable environment. I did that. So here's my evidence. I'm just telling you that, oh, by the way, wink, wink, I added a equals 5 to the variable environment, just so we have some kind of confirmation from our interpreter right now that something happened. All right, so that's for interpret remember statement. And right now in our interpreter, we're only interpreting remember statements. That's all I'm doing right now. So go back to driver. And actually, hold on, let me go back into my Spider interpreter. I'm gonna make my output public just for now, because this is just showing me the output of, well, actually, I'll make it private. I like calling functions instead. So we'll have a public static void. We'll ask our interpreter to display results. And what this guy will do is it'll say for string s in Spider interpreter dot the output system.out.println s, like that. And then what I'll also do is I'm going to just beforehand, I'll say system.out.println current variable environment. And then I'll say Spider interpreter dot the env dot display. So I'll go ahead and ask my variable environment to display itself to the screen. Then I'll show the output of my program, just so we'll have double validation. I should see that, oh, we added something to our variable environment, but we should also see that, oh, it actually was added to our variable environment. So this will be a function called display results in our Spider interpreter. That'll go through all of our output things. All right, so now I parse my stuff. Then I interpret my stuff, and then I'm going to ask my Spider interpreter to display the results. Now, even though my input Spider here has 2 remembers and 2 resolves, my interpreter does not know how to interpret resolves yet. Guess whose homework that's going to be? All right, so, but it shouldn't be hard. I think I'm giving you quite a bit of a starting point example for this. All right, but it should give me my, here's my current variable environment. Hold on a second. I have an a equals 5 and a b equals 7. Oh, that is correct, because I defined an a equals 5 and a b equals 7. I was only thinking about my first value there. Sorry about that. Okay, so my variable environment has 2 variables stored inside of it. And then here's the 2 hidden lines that it added an a equals 5 to the variable environment and added a b equals 7 to the variable environment. Okay, so there's my interpreter processing through my list of statements. In this case, only dealing with remember statements. I only deal with remember statements here. So we want to had the ability to handle resolve statements. Yeah. All right, so let me go ahead and starter code for homework number 4. Push to origin. All right, so now you have the starting point for that. All right, so questions about what I'm asking you to accomplish for Monday.
So yeah, my question is like the result statement will be the output of the variable, like the A value is 5, so the output of the result statement will be 5, right?
Correct. So maybe your maybe the output should hold something like hidden resolved A equals 5, something like that. That you looked up in the variable environment for the variable named A, you found that its value was 5. And that's maybe what you put in your output. Because later on, we would be using that value as input to something else. So for instance, in Java, I wouldn't just be able to say A. I would have to say something like system.out.println A. Or you'd have to say something like A is equal to A plus 3. That kind of stuff, math statements, where that's when you would resolve the value of A to use it as part of another statement, which is where we're going to be going next week. Okay, but for right now, we just want to prove that we can look up, we can resolve a variable to its value. So I'm basically asking you to be able to follow my code and add an additional if statement here with an additional function. Make sense?
Oh yeah.
All right, other questions?
Question.
Sure.
So in the GitHub, like when I try to fork, I cannot able to because it's only showing me what I forked last time. It's not letting me update.
Yeah, I think You could either delete your repository and then fork again, or you can do what's called a pull request, which would update your repository to my current repository.
How do I do that?
It's on GitHub. Just do a Google search for pull requests, or do a Google search for update my repository to the latest from where I forked or something like that.
Yes, I also was confused. I was trying to delete my repository and I did 2 times and it was not showing. So I don't know. Anyway, I will find in Google. I don't know.
Yeah, I mean, all you're trying to do is start with my code as your starting point. So you can delete your old repository. I mean, preferably you would pick up where you left off on your code. So rather than start with my code fresh, you would bring your code up to date with mine if you needed to fix bugs or something like that, and then you would add to it for the next homework assignment. But if your code is so far beyond repair or something like that right now, and you want to start with this new starting point, that's okay. But my preference would be for you to keep building your version of this in the spirit of what we're doing in class.
Okay, I have a question. If I am keep adding in my same repository, I don't have to create again. It will be added to the same GitHub.
Well, correct. If you're just updating your own repository every single, you see me do it several times today where I come in here, I commit changes and I push it. If you just keep doing that, then it's a non-issue. You're
Okay.
your own repository. You don't need to re-clone mine to pick up where you left off. The only reason you clone mine to begin with is to give yourself a starting point. You didn't have to do that.
Okay.
All right, other questions?
In my output window, somehow it gets disappeared. So how do I bring that back? It gets on the right side instead of the bottom.
Well, it should automatically come back if your driver does something. So make sure that your driver is doing something. So if you don't have any of this stuff in there, so if I comment this stuff out, for example, and I run this, I'm not going to get an output window. But if I add like a system.out.println, hello in here, now my output window will pop up.
One time I accidentally hit the cross button on the top.
Right. Yeah, so I close that and then I run it again, it pops back up. So just make sure your main is outputting something. As long as it's outputting something, it'll pop the console back up.
Do I need any other? Because I don't see any other available.
Do this. Go up to window.
Besides.
You go up to window and then show view and show console, it'll probably pop it back up too.
Okay. Do I need this declaration, Java doc, and problems in the console?
Well, what do you mean?
Like there are like 3 different kinds
3 different kinds
of windows in the console. Yeah, you see there are problems, Java doc, and declaration.
Oh, yeah. I mean, which one am I on right now? Standard out changes. I mean, it should just look like this.
Yeah, I don't see any declaration, Java doc on the tab on the top here
Java doc. What are
by
you?
the console.
Okay, I'm on the console right now.
Right.
Oh.
So there is a declaration, Java doc, and problems. I don't see those 3 in mine.
Yeah,
Is it required?
Trying to get. You're just asking me to have to get your console back up. So there's your console. The declaration is something different. That's a different tab.
I don't need that.
Well, have we used it yet?
No.
So, I mean, until you need it, you don't need it. Yeah, our console is where we're looking at our output right now. So did this get your out? Did you get your console back?
Yeah.
Okay. All right. Anything else?
So we can make changes to our existing repo if it's good, right?
Yeah, that's my preference actually. My
Okay.
preference would be for you to keep working on your own parser and interpreter and letting it evolve and not have yours look almost identical to mine. But you know, if you get yours into some state where it's completely destroyed and it's going to take you forever to fix, and you want to start over with mine, that's fine. Otherwise, just use mine as a reference. If you wonder why something isn't working in yours and you can't find the bug, look at mine and see how I did it.
Okay.
But definitely my preference would be for you to just keep giving me your GitHub link that picks up where you left off, not where I left off. All right, anything else? Going once. Going.
Yeah, I have a question regarding like I've read in one of the articles that if after doing parsing, there is another step called abstract syntax tree.
Yeah, that's typically if you're going to use be doing a compiled language.
Mhm.
But if we're doing something as a compiled language, you would create an abstract syntax tree because that's what you would actually apply the compiler to, because you actually do syntax checking ahead of time. In our case
Oh.
here, we're interpreting, but we're also kind of assuming that our syntax is written correctly because we're focused more on the language constructs than we are on, you know, making a real language that we would release to the public or something like that.
Okay, okay.
So really what we're focusing on are how are programming languages built under the hood? Like how is an if statement implemented? How is a for loop implemented? How is recursion implemented? Things like that. That's what we're exploring in this class, to have an appreciation for the languages that we're already using, you know, because realistically, you know, you're probably not going to write a programming language from scratch, but what we're doing in here would allow you to create an interpreter to maybe make your life easier. If you do the same thing in Java all the time, you can do something a little bit, you know, a little bit different or something. But, you know, in general, we want to just have an appreciation for how things are actually implemented under the hood, because that helps us become better programmers, understanding how a language is likely to behave under certain circumstances. Make sense?
What
Yeah.
about HTML parser?
What about a what?
HTML parser.
Well,
I
what
heard HTML parser. Is that hard to?
are you saying, an HTML parser?
Yeah.
Well, I mean, the HTML parser is parsing HTML and turning it into meaning, but so instead of it being a programming language parser, it's a data representation language parser. So, I mean, it's not any different than what we're doing here. I mean, HTML is a tag-based language, so you're going to be searching for the beginning of tags and also the corresponding closing tag. So it is a different approach, because we've built our language here to be a, you know, semicolon separated. So if we think about this as HTML, this is a tag, this is a tag, so on and so forth. And then we discern meaning from that tag. But HTML is going to have things in there, you know, like
Yeah,
body and
like a
then
body and
slash body.
yeah.
So we know that this tag starts here, and then we search for the corresponding ending tag for that guy, and know that the stuff in between is part of that portion of the, you know, the HTML.
Yeah.
But HTML is not a programming language; it's a data representation language, which is fine. And you would build a parser for that, similarly to how we built a parser for this. You would just match up your stuff a little different.
I have a question. We haven't reached that part yet, but I'm curious, what is your idea of implementing the variable environment say under another variable environment. Say if you have a code block.
Scope, where we have a more local scope for a function.
Mhm.
Yeah, so we'll
Mhm.
create another instance of our variable environment that'll take precedent over the current one. So what we'll end up having is probably a stack of variable environments. So whatever's at the top of the stack is the current variable environment we're looking at. And then if we don't find the variable we're looking for in there, we'll pop from the stack and look at the next variable environment.
Okay, so you are going to adding the stack to the variable environment. Say
No,
a stacks of variable environments.
correct. A stack of variable environments.
Okay.
All right, anything else? All right, so your homework is up. My repository is up to date. I will make sure you're using Slack if you have questions when you're working on your homework, and I'll either answer them or one of your classmates will answer them. And then I will see everybody on Tuesday. We'll probably be online again on Tuesday just because of the other classroom, but my intention is to be back in person next Thursday. All right, but I'll announce for sure, but you could probably plan on being online on Tuesday.
Tuesday or Monday?
Oh, I'm sorry, Monday. Yeah, our class is Monday, Wednesday. So everything's due on Monday. I should actually check when I made the homework assignment due here because I want to make sure you turn it in before it's before I go over it. Yeah, I made it Monday. All right.
I have a question. In a Monday's assignment, if in case we get late to submit on Tuesday, it means in Wednesday morning, what will happen?
So
Means,
you don't turn Monday's assignment in until Tuesday? Is that what you're asking?
means if we submit little late, if some reason, sometimes stuck and take long time to figure it out.
Well,
So
you should turn in what you have done on time.
Okay.
Because I go over it in class. So that means that after I've gone over it, you have the real solution. So if you can't quite figure it all the way out on time, then that's fine. That's what the self-assessment is for, to tell me where you struggled. But at the same time, you should submit it because I won't take it late because I go over the solution. That make sense? Because I mean, as of right now, you have what? Thursday, Friday, Saturday, Sunday. You have over.
It's a lot of time we have. It is,
Right.
but Monday's one is sometime,
So turn it in on time is the punchline.
Okay.
Bad things will happen if you don't. This is the short answer. All right. Well, I will see everybody on Monday.
Have a good day.